the death of the all-printed rocket. Relativity Space just abandoned the very technology that made them a multi-billion-dollar company. Their pivot from a 100% 3D printed rocket to a hybrid manufacturing model for the Terran R is a cold admission that marketing does not beat physics. While they once promised to print entire rockets in 60 days, the reality of building a heavy-lift vehicle in 2026 has forced them to bench their massive Stargate printers for the most critical structural components. This isn't a failure of innovation, but a surrender to the brutal requirements of orbital flight. The move reveals a fundamental flaw in how we thought additive manufacturing would scale. The physics of scale penalty. When you 3D print a propellant tank the size of a building, the physics change for the worse. 3D printing works by melting metal layer by layer, which creates massive internal heat stresses and the risk of microscopic voids. To ensure these huge tanks don't burst under pressure, engineers have to make the walls thicker than they would be with traditional materials. In the rocket business, this is the weight penalty. Every extra pound of metal added to the structure is a pound of satellite you cannot carry to orbit. By switching to traditional high-strength aluminum alloys for the main tanks, Relativity is stripping massive amounts of dead weight from the Terran R design. The math of the 3D printed tanks simply stopped working as the rocket got bigger. When seconds outpace robots, time is the second killer. While a 3D printer can run 24 hours a day, it is actually slower than a traditional factory for long, simple shapes. A friction stir welding machine can join massive sheets of aluminum into a rocket body in a fraction of the time it takes a laser to deposit metal grain by grain. To hit their 2026 flight schedule, Relativity had to choose between the novelty of the printer and the speed of the forge. They chose the forge. This shift allows them to mass-produce the simple parts, like the fuselage, while focusing their specialized tech where it actually provides an advantage: the 3D printed heart of the beast. Relativity didn't kill the printers entirely, they moved them to the engine bay. The Aeon R engine is a nightmare of internal cooling channels and complex geometries that are nearly impossible to make with traditional drills or lathes. This is where 3D printing wins. By printing the thrust chambers and injectors, they can combine hundreds of parts into a single piece of metal. It is a strategic retreat. They use traditional methods for the easy, giant parts and 3D printing for the hard, complex parts. This hybrid approach is the only way for a startup to compete with the manufacturing scale of SpaceX or Blue Origin in the current market. The end of the additive myth. Relativity's pivot proves that being a tech company is not the same as being an aerospace company. By sacrificing the 100% additive manufacturing narrative, they chose survival over branding. This decision highlights the maturity of the 2026 space market, where venture capital no longer funds interesting experiments, only successful launches. The weight penalty and the speed bottleneck forced a pivot that every other additive startup is now quietly following. The era of the fully printed rocket is over before it even began. This actually accelerates our path to orbit because it moves 3D printing from a gimmick to a surgical tool. Watch the Terran R integration test this summer. If their friction stir welds hold under cryogenic pressure, this hybrid model becomes the new industry standard for everyone chasing the heavy lift market. The signal here is clear. The winners of the next decade won't be the companies with the coolest tools, but the ones who know when to put them down. Subscribe for more.